Namaskar, good morning to everyone. So welcome back to the CTET Mathematics Preparation 2026. So I am Manohar, Senior Research Fellow, Department of Education, RI, Mysore. So in today's session, we are going to discuss about square and square root. So what is the square and how we can identify the square and how we can identify the square root. So in these concepts today in this session we are going to discuss. So coming to the next, so we also see. So if you observe, previous question papers of the CTET, so for particularly from this concept, so especially they are asking every year in the paper 1, paper 2, 2 to 3 questions every year they are asking. So that is the weightage they are giving for this chapter. Okay. So based on 2 to 3 questions they are asking based on these represented concepts. So that is perfect square and based on the square root and how we can identify the perfect square and square root based on the prime factorization method and division method, and also least number to add and multiply. So what is the least number to add to in order to identify the square root and in order to identify the perfect square. Okay. So another concept also, decimal square root and square root of fractions and simplification using the square root and number properties. So based on these concepts in every year CTET paper 1 and paper 2 they are asking 2 to 3 questions in the every year in the CTET exams. Now so there is one question which they asked in the previous question paper. Let us see this question. What is this question and how we can solve this one. So what is the question here? The question is the square root of 1089 is. So what they're asking here, what they're trying to ask here, the square root of 1089. So there is a number they have given 1089. We need to identify what is the square root of that number. So what are the options they are given here? Option A is 32 and option B is 33 and option C is the 36 and option D is the 39. We need to see which is the correct answer. So now, we don't need to follow the regular method in order to find the square root of this one. By seeing the question itself we can identify. Okay, so now let us look at here. What is the square root of the number they are given? 1089. So what is the options here given here? 32, 33, 36 and 39. Let us check the options and try to see the elimination method. Okay, so now in the given number 1089, let us observe the last digits. Okay, 89. So in the 89, 9 is unit digit is ends with the 9. Similarly, when you see the options, look at the options which is the number which is ending with the square of that number is ending with the 9. That is the option. If you look at the option here 32, so last digit of the number, what is the last digit of the number in 32? 2. Okay, so 2 square is 4. So does it end with the 9? Does it match with the 9? No. So if you see the option 3, 33, 3 square is 9. So 33 is there is a possible to get the answer. Okay, so this may be the answer. Okay, so then if you see the 36, okay, 6 is 36. Again 6 is ending, unit digit is ending with the 6. If you see the 39, so 9 nines, 9, what is the square? 9 square 81. 1 is ending, unit digit is ending with the 1. So there is no chance of answer of this one. So option C, option A is not the correct answer, is the 33. But let us verify by using the prime factorization method. So what we have to do whenever we such a questions asked, okay, the square root of given any number. So what we have to do, immediately we have to apply the prime factorization method. Okay, so now how we can do the prime factorization method here? Now let us see. Let us try to identify. Okay, so now for 1089, let us try to identify what are the factors. So 1089 we can be written, it can be written as 11 into 99. Okay, and then 99 can be written as again 11 into 9. Okay, so then 9 can be written as again 3 into 3. So again 3 can be written as 3 into 1. So here 11 and 11, 3 and 3 are the becomes the factors of the 1089. Okay, so now if you see here, the factors are coming in the pairs of the numbers. Okay, so 11 into 11, 3 into 3. Okay, so this we can be written as 11 into 3 square. Okay, so then if you multiply this one, you will get the 33 square. Therefore the answer is the square root of 1089 will become a 33. Similarly, so whenever you try to apply the factorization, we have to look at the pair method, we have to see that. Okay, so when you do like the pair method, so we'll get the answer. Okay, so here 10 and 18 both are the pairs of the 33. So therefore we say that 1000 square root of 1089 is equal to 39. So 39 square is the value of this one. Okay, so that is the, from this we are confirming that option B is the correct answer. So in exam, in the CTET exam, whenever they ask this question, you don't need to solve like this. By seeing the options, we can use the eliminate method. Observe the first digit. Okay, in the first digit, whether given option, whether which first digit, unit digit is ending with that number. Okay, so in such a cases we can solve like this. So now let us see what are the concepts which applied in this question in order to solve this one. One is the perfect square concept and another is the square root concept, are they applied here. So what is the perfect square here? Perfect square is a number is called a perfect square if it can be expressed as the square of the whole number. Okay, so for example, let us like, okay, 1 square is the 1, 2 square is the 4, 3 square is the 9, and 16 4 square, and 25 5 square is the 25, 6 square is the 36, so on and so on like this. Okay, so these squares, okay, of when you again multiply with them, which it has to get the whole number. So this we say that is a perfect square. In the square root of a number, it is a value which when multiplied by itself gives the original number. Now we have the square root of 25. So when I multiply this, this square root, it has to be given original number. Okay, so that means like 5 into 5, and again if I multiply, it has to give the 25. Again, the whole number 6, if I multiply again 6, it has to give the 36. This is the concept of the square root. Okay, so now, so what we have done for in order to solve this, in order to identify the factors of the square root, we broke the 1000 given number into the prime factors, and all prime factors occurs in pairs, okay, which we identified, and therefore we say that it is a 1018, it is a perfect square. Now take one factor from each pair, and we always prime factors we get it, perfect squares we get it in terms of the prime factors. Okay, now let us take the each prime factor and multiply. Okay, so such as like now 11 we got it into the pair, and 3 also we got it into the pair. Okay, so now from each pair we have to take the single one number and we have to multiply, then we can say that the number obtained number whichever we got it, that is the perfect square. Okay, so we have to remember this one thing always: if all prime factors occurs in the pairs, then we say that it is a perfect square. In order to say that whether the given number is a perfect square or not, we have to see that all prime factors occurs in the pairs. Okay, this is the one example which we have discussed now. Now coming to the second question, the question is like this: what least number should be multiplied by the 245 to make it a perfect square? Okay, this is not the perfect square. Okay, to make it this is a perfect square. In order to make it is a perfect square, which is the least number we need to apply here, whether it is a 2 or whether it is a 3, whether it is a 3, whether it is a 7, which is the number least number multiplied with 245 to make it a perfect square. Let us see now. Okay, so for this also, like whenever they ask the least number, yesterday when we were discussing about the LCM in itself, so we have discussed that. Okay, whenever they ask like maximum minimum, okay, so we are trying to apply the factorization method. Okay, now for this try to identify the factors. Okay, 245, the factors of 245, 5 into 7 into 7. Okay, so 245 we can write it as 5 into 49, and 7 we can, and again 49 we can write it as 7 into 7, and 7 we can again write it as 7 into 7. So therefore we say that the factors of 245, 5 into 7 into 7. Now if you observe the 5 into 7 into 7, 7 is again it is in the pair. Okay, 7 square, but whereas 5 is not in the pair, so that means we need one more 5 in order to make it a perfect square of this 245. So what we have to do in such a case, so for a perfect square always powers must be the even. So now if you observe here 5 to the power of 1, it is in the odd, it's not even. So therefore what we have to, we need to again add multiply the given number with the 5. Okay, so now 5 to the power of 1, it is unpaired, so to make it even we have to multiply with the another 5. Okay, so now 245 of the given number, so 245 5 into 5, so that becomes a 1225. Okay, so now this we can expand. If we simplify, we'll get it the 5 into 7 square, that is becomes a 35 square. Okay, so now which is the least number we are trying to add to make it a perfect square? That is the answer 5. Okay, answer option C is the correct answer, so another options are the wrong answer. Okay, so this is the one way of solving this question. So what we have done here, we check the number, we identify the prime factorization, we check whether it is a pairs are available or not of the given factors, and then we took the unpaired factor, and the unpaired factor we multiply with the given number, and we got the perfect square. Okay, so multiply remaining unpaired factors in order to make it a perfect square. Then question 3, find the square root of, again, so this is another question, find the square root of 18,769. So they are given one number, so 18,769, we need to identify the perfect square. So in the previous problem, we also try to identify the square root of the given number. So that is through the prime factorization method. Since the given number is 245 is the very smallest number, we try to do the prime factorization method. But whereas in the large number, when they give like this large numbers, how we prime factorization method doesn't work sometimes. Okay, so in such a case, we try to use the long division method. So even without using the long division method also, we can try to guess the answer here. Okay, now same in the similar, in the given number, let us see 18,769. what is the last digit of here? Last digits of the number is ending with the 69. Okay, and the similarly options you see that. Okay, so what is the, which is the option, if you see the 135, last digit is the 5. Okay, so 5 square is 25, so does it end with the 9? No. So 9, if you see, again option B, if you see 149, okay, 9 square is 81, 1, so doesn't end with the 9. Now if you see the 7, okay, last digit 7, it probably end with the 9. 7 square, 7 into 7 is the 49, so there is a chance to get this answer. Now again, if you see the 151, 1 doesn't end with the 9. Okay, so we can say that maybe we can guess that maybe this is the option for this correct answer for this question. Okay, so but let us try to see that, okay, whether it is correct or not. Now what is the given number here? 18,699, which ends with the 69. The square of the number ending with the 7 also ends with the 49. So therefore we are confirming with 7 is maybe probably answer. Okay, so but let us try to see the by using the long division method. Okay, now how we have to do the long division method? We have to go back to remember. So 18769 they have given here. Okay, so what we need to pair the numbers from the right side to left side. Okay, now this is become a one pair, this will become a one pair, this will become the one pair. Okay, so there are 3 pairs which we have got it here. Now what we have to do, now see the 1 which is the largest number of near to equal to the 1 and less than the 1. So there is only one probability is 1 square is equal to 1. This is the 1. Okay, so now 1 we keep it here, and in the quotient 1 we keep it here, and becomes a 0. Now bring that down both pair 87. Okay, now make it a double of this 1, the quotient which we got it, that becomes a 2. Now we see that 87. Okay, which number can be possible to get it the 87 nearest value. Okay, so now 2 we have, let us try from 1 to 9, we have to apply the trial and error method here. Okay, now since 7, so 21 into 1 again 21, 22 into 2 again, if you do 22 into 2 again, it is 44, it is not near. Again if you do 23 into 3, you may get it 3 3 is a 9, 3 2 is a 69. Okay, which is near to 87. Let us see that. Okay, 23. So now 3 we keep it here, again 23 we'll get so we will put the 69 here. So when you subtract this, we'll get the 18. Okay, now we have the 18, and another pair we have that as it is, we'll bring it to here. Now 18, 69 we got it. Now it is this 2 and this 3 again we make it a double here, 26. Now again one more number which is required here. Okay, so now since we have the 1869, look at the last digit. Okay, 9. Okay, so recall what is the number which is which is ending with the 9. Okay, so if you recall like 7 square, if you do 7 into 7, maybe 49. Okay, where this is also ending with the 9. So now let us try with 26 we have, and then we are trying to multiply with the 7, which is same number. Okay, so now if you multiply this, 7 7s are 49, so we'll get 18,069. Okay, 18,069. So therefore we say that when we get the remainder 0, we say that so this is a number, okay, which we got at the final. So therefore we, by long division method, we are confirming that 18,000, the square root of the 18,069, the value is 137. So we can also follow the long division method in order to find the square root of, and also we can do the elimination method also, we can do that. Okay, so this is what we have done. So first we make it into pairs, and we check which is the largest square, and we also see the Taylor divisor, and we see that whether it is a obtained number of perfect square or not. Okay, so as we have done. Now there is a question, another question which they have discussed. Find square root of 2074 divided by 81. Okay, so now they are given in the square root of in the fraction form. Okay, so now we need to find what is the value of that one. Okay, so for this, what we can do, whenever they give this kind of question, let us remember the form of this one. Okay, so this is in the form of root a by b. So that means the square root of a fraction is equal to the fraction of the square roots. Okay, so that we can write it as root a by b, we can write it as root a by root b. Okay, so now let us try to apply this formula in this in order to get the solution. Okay, so without that, so before applying, let us also see the options. The options that are given, option A is 52 by 9, and option B is the 58 by 9, option C is the 42 by 9, and option D is the 48 by 9. Okay, so now 81, if you see the 81, 9 square is equal to 81. Okay, so that means the denominators all are equal. Okay, there is a chance, okay, for all the numbers. Now if you see the 2704, okay, last digit is end with the 4. Okay, now let us see the last digit, whether it is the square of that number, whether it is end with 4 or not. Okay, now if you see the 2 square here, 2 square is 4. Okay, there is a chance to end with 4, and 8 square, if you say 8 into 8, 64. Okay, there is a chance. Now 42, if you see 2, again 2 square 4, there is a chance again. Okay, so you have to check now. So if in this method doesn't work for this, now let us try to apply this one. Okay, so now you have to identify the square root of the 2704. Okay, so that will becomes a 52. Okay, so therefore we say that the answer is a 52 by 9. So how we can say that we here also. Now 4 is the, probably there is a unit digit ending with the 2, and then 27 we have to check the nearest. Okay, so then we 5 square is equal 5 into 25. Okay, so then you try to see the 52 into see the number. Okay, so then we may get it the answer. Okay, so this is the one way of solving the problem. So which is the concept we are applying here? So the concept of is the square root of a fraction is equal to the square root of the numerator divided by the square root of the denominator. So that is root a by b equal to root a by root b. So this value will be the equal same. Okay, so that is the one example which we have discussed. Now another question. The question is like this: find the square root of 147.1369. So options they are given: option A 12.14, option B 12.13, option 3 13.26, and option D 13.13. So we have to see which is the correct answer. So we have to find the square root of the given number. Now, so this is also they are given in the form of decimals. Okay, now what we have to separate the decimals, and then we have to try to identify the square root of the given number. Now separate the decimal part in pairs from the right to left. Okay, so we have to separate it first. One part of decimal part, left side of the decimal part separate, and whole part and decimal part in pairs are separate. Okay, then we have to find the square root using the long division method. So when you use the long division method, we will get it. So so let us try to solve first for the square root of the whole part, 147. Okay, so we divided into pairs. Okay, 47 is the one pair, 1 is the another pair. Okay, now when you do the long division method, 1 is a 0, so then we take it, so remainder is a 0. Again we take it is 47. Okay, 47 is the next pair, so as it is we will take it, and this will make it a double. Okay, so then we'll get it a 2, and then we have to see that which is the number possible to nearest value of the 47 or nearest value of the 47 or equal to the 47. Okay, now if you see the 24, okay, there is a chance. Okay, so if you see that, okay, so we'll get it 12 point for this 12.13. So when you do the long division method, we will get it the answer like 12.3. So therefore we say that find the square root of 147.136 is the 12.13. So this is also one way of the getting the answer. Now only even you don't need to do completely division method. So we can say the 147, and we can also throw the elimination method. So once we get the 147, we can confirm that the option must be either A or B. So that that the C and D cannot be part. Okay, so again we have to check the 1369 through the do the line division method. Okay, and then check whether 0.14 or 0.13. Okay, so when you do that 0.13169, okay, the similarly we'll get it the answer of 13. Okay, now the another question, square of 9e9 divided by the cube root of 125, find the remainder we need to identify. Okay, they are given options like this. Option 1 is 1, option 2 is the 3, and option 3 is the 5, and option 4 is the 7. Okay, now what we need to do here, the square of 9 divided by cube root of 125. What is the square of the 9 here? 81. What is the cube root of 125 here? 5. So now what we need to divide both of them. Okay, so that means 81 divided by 5. If you do that, you will get the 16.2. Okay, now what is the quotient here? Since it is in the decimal point, we will make it approximately near to 16. Okay, so now what we need to find, the remainder we need to find here. Okay, so now how we can find the remainder? By applying the remainder in formula. Okay, so dividend minus divisor into quotient. Okay, so now what is the remainder here? Here 81, and then remainder we need to identify. So what is the dividend here? 81 and minus 5 into divisor, and 16 is the quotient. Okay, so now when you do the calculation simplification, you will get the 1. So what is the remainder here? We got it the 1. Okay, so this is the concept which is involved in that. Square of a number, square means multiplying a number by itself, that is a square is equal to a into a. So example, as we have discussed in the previous questions when we are discussing, and the cube root. Okay, so reverse of the cube root, 3 root a is equal to b if b to the power of q is equal to a. Okay, so this also we'll discuss in the next coming the session. Okay, so these are the examples like 2 to the power of 3 is equal to 8, 3 to the power of 3 is equal to 27, and 4 to the power of 3 is equal to 64, 5 to the power of 3 is equal to 125, so which we need to remember some of the things. Okay, so and then this is a concept where it is involved. Okay, step 1 we try to identify what is the 9 square value, 81, and then we try step 2 we try to identify cube root of 125. Okay, so we got it the 5, and then we divided, and then we got the quotient is the 16, and then by applying this value we find the remainder. Okay, so answer we got it the 1. Why other options are not wrong? So this is the divisor, not the remainder, other in the given option. So 5 is this is the cube root, not the remainder. 7 is obtained from the incorrect option, we didn't get any 7. So only option 1 is the satisfies. Okay, now next question, which of the following number is a perfect square? So now we need to identify which of the following number is a perfect square. Okay, now the options are given 5, 4, 8, 5, 4, 3, 2, 4, 1, and 5, 4, 8, 5, 4, 2, 1, 4, 1, and they are given for third option is 4, 5, 8, 5, 4, 3, 2, 4, 1, and fourth option 5, 4, 8, 5, 4, 3, 4, 2, 1. So there are large numbers they are given. We need to see which is the number is a perfect square. So how we can check that? Okay, so you just check with the last 2 digits. Okay, so we eliminate options. Okay, but we let us try to see that whether it does it work or not. Okay, now what we have to see the last digits. So what are the last digit we got it here? All options ends with the 1, 1, 1. Okay, a perfect square ending with the 1 must have the square root ending with 1 or 9. So all the options are the possible. So if you remember, okay, 1 probably it may end with the 1 or 9. Okay, so if you see the options here, all the options are having the ending with the 1, so therefore there is a possibility. Okay, all are the possible. Now estimate the square root here. Okay, so what we have to estimate the square root. Okay, now for 23,000 square, it may become a 529 for 529. 24,000 square, it will become a 576,000,000. So our number lies between these two numbers. Okay, so now its a square root lies between either 23,000 square or 24,000 square. So now we can estimate like this and try to see that, okay, which is the near the square. So now 23,400 square, the value of this one is 54755600, and this is a very close to number. Okay, so the square root is around maybe 23,400. Okay, and then find the exact square root we need to identify. Okay, then so if you solve like this one, okay, we need to increase all the square and we have to identify the differences. Okay, so then so when you're trying to solve this, we can apply the formula a plus 1 whole square is equal to a square plus 2a plus 1. Okay, so when you apply this, the value which we got it, this one, so we may get this value. Okay, so because we need to identify what is the perfect square. Okay, so we have to make it a double. So by applying, we're doing this calculation, we will get the answer 4241. So which is this option 1 is the correct answer. The next question is, if a is equal to 2013 square 2013 square plus 2013 plus 2014, find the root a. The options given options are 2012 option 1, option 2 is 2013, option 3 is the 2014, option 4 is the 2015. Okay, so which is the root a value, we have to see that. Okay, now what is the, if a is equal to 2013 square plus 2013 plus 2014, find the root of a. So what we have to first, we need to identify what is the a value here. Okay, now given a value is 2013 square plus 2013 plus 2014. So now let us try to rewrite the expression here. Okay, so a is equal to 2013 square plus 2013 plus 2014. Okay, so that we can again 2014 again we can write it as 2013 plus 1. Okay, so that means we can become a uniform. Okay, so we are bringing into the uniformity. Okay, 2013 square plus 2013 plus 2013 plus 1. Now use the identity here, x square plus x plus x plus 1, that is becomes x plus 1 whole square. So what is here, x is the 2013. Okay, so now a is equal to 2013 square plus 2013 plus 2013 plus 1. So again if you simplify this one, we will get it the 2014 square. Okay, so what we need to do for this, we need to identify the root a. So we got it the a value this much. Now we need to identify the what is the root a value, we need to identify. So therefore if we get this cancelled, this will become 2014. Therefore root a is equal to 2014. Okay, look for the pattern. So whenever given problem like this and apply that pattern, we'll get the solution. Now next question is, least number to be added 8,93,304. So 893,304 to obtain the perfect square. Okay, so find the next perfect square to greater than the given number. So what are the options that are given here? So what is the question here? Least number to be added to the 8,93,304 to obtain the perfect square. So what are the options they are given? 1008, 1207 they are given, 162, option 3 is the 1612, option 4 is the 1816. Okay, now let us see which is the correct option. So find the next perfect square greater than the given number. So what is the given number here? So we need to identify which is the perfect square of next perfect square. So if you see that for this 8,93,304, the perfect square may be 945 square. Okay, so now you have to check the 945 square whether it is a less than the perfect square or equal to that number or less than that number. So if you see that this is you will get 89,3025, which is less than the given number. Okay, so what is the next perfect square? 946 square. Okay, so 946 square, so if you if you do that one, we'll get the 8,94,916. So now find the difference of that. Okay, what is the least number to be added to make it a perfect square? Okay, so 946 square minus 945 square if you do, so it means this value if you subtract, we'll get the 1612. So therefore answer becomes a 16. Option 3 is the correct answer. Okay, then so what is the method we can remember here? If n is close to a perfect square, check a plus 1 a square, and where a square is greater than the n. Okay, so that is what they are saying. Okay, so we try to identify the next perfect square of the given number and try to see the differences of that one, then we'll get the answer. Okay, now the next question is, if square root of 18 into 14 into x equal to root 168, find the x. What is the options they are given here? 1 by 2, option 2 is the 2 by 3, option 3 is the 3 by 2, option 4 is the 2. Okay, so how we can solve this problem? let us see that. Okay, now square the both the sets. Okay, now we have to find the x value, we need to find. Okay, so not the square value, so therefore they are given in the form of square, so therefore we try to remove the squares here. Okay, so that is square the both the sets. Okay, so now if you square the both the sets, what will happen? This one will get the cancel. Okay, so now 18 into 14 into x is equal to 168. It will be. Now what we need to identify, we got it the simplified we have, so we need to identify the x value here. So now that will become 168, so this LHS value become the right side, becomes a divisor. Okay, so 18 into 14, so x is equal to 168. If you multiply 18 into 14, we'll get the 258. Now let us simplify this one. So x is equal to 168 by 252. If you do this, okay, 2 by 3, we will get it. So what is the answer? Is there a 2 by 3 answer in the given options? Yes, 2 by 3 is the second option. So second option is the correct one, and option 1, option 3, option 4 is the wrong answers. Now what we have to do whenever they give this kind of questions, try to find the try to remove the square roots, and you'll get the value. Find the x value, then find the x value and simplify the equations, then you will get the answer. Okay, so yeah, now next question, if 52,272 equal to p square into q cubed plus r to the power of 4, find 2p plus q minus r. The options are given like this. Option 1 is the 20, option 2 is the 21, option 3 is the 23, option 4 is the 25. So now let us see which is the correct answer. So now what they have given, if 52272 like 52,272 equal to p to the power of square and q cubed plus r to the power of 4, then what is the value of the, we have to find the 2p plus q minus r. In order to find, first we need to identify what is the p value, q value, r value. So then we can, once we get the p value, q value, r value, then we can substitute and can find the solution. So let us see now that. So since it is a, so number has given, so square root we will try to identify. Okay, prime factorization of the 52272. Okay, so now if you do the through the prime factorization, we will get the 2 to the power of 4, 3 to the power of 3, 11 to the power of square. Okay, so this can be divided with 26,136. Again this can be divided with 13,068. Again this can be divided with the 2, 6, you will get the 6,534. Again 6,534, if you divide with the 2, we'll get the 3267. Okay, now since 7 is the odd number here, we cannot divide with the 2, so let us try with the 3. Okay, now if you divide with the 3, we'll get the 1089. Again 1089, if you divide with the 3, we'll get the 363. So again if you 363, if you divide with the 3, we'll get the 121. So now let us check with the 11. Okay, so 11 11s are 121, 11 ones are 1, so the remainder is the 1. So therefore this all will becomes a factors of that. So how many 2's are there here? 1 2 3 4. So therefore 2 to the power of 4. How many 3's are there? 3 are there. Okay, 3 to the power of 3. So how many 11's are there? 11 to the power of 10. So this is a fact from prime factorization of the given number. Okay, so all the we have to remember that prime factors always it will be in the even number. Okay, now compare with p to the power of square, whatever the prime factorization we got it, these numbers let us compare with the p square, q cubed and r to the power of, and try to identify what is the r value, what is the q value, what is the p value. Okay, so what are the primes here? We got it 2 3 11, that is 2 3 11. Okay, so powers in this, what are the 2 to the for the prime number of 2, what is the power? 4. Okay, similarly for the 3 it is a 3, similarly for the 11 it is a 2, 11 to the power of 2, 3 to the power of 3, 2 to the power of 4. Okay, so now let us match with this. Okay, so 2 is, so p to the power of 2, q is q cubed is, it is the power of 3 to the power of 3, and r to the power of 4 is the power we got it in 4, so this is the 2. Okay, so therefore we are considering this like p q r values like this. Now where r is equal to 2, q is equal to 3, p is equal to 11. Okay, r is equal to 2, q is equal to 3, p is equal to 11. Now what we have to do, substitute the identify the value p q r value. Okay, so now what we need to identify finally? 2p plus q minus r. Okay, so now substitute the values in this. Okay, so now 2 into what is the p value? 11. So substitute 11 plus what is the q value here? 3 substitute, and what is the r value here? Minus 2. Okay, so when you substitute, so 2 into 11, 22 plus 3 minus 2. So when you simplify this one, we'll get the 21. So the final answer we got it the 23, which is the option 23. Option 3 is the correct answer for this given. So 23 is the value of the 2p plus q minus r, okay, from the given number. So what we are trying to do here, so we are trying to express the given number into the prime factorization, okay, and the product of prime numbers which is raised to their powers, okay, and then we are matching with the powers with the given number, given numbers p square plus q cubed plus r to the power of 4, and take the prime whose power is 2 as a p and whose power is 3 as a q, whose power is 4 is also r, and substitute these expressions into the given values into the expression, then we'll get the answer. Okay, so these are the some of the questions where we have in the paper 1, paper 2, most of the repeated questions where they covered from the paper 1, paper 2 from the concept of the square and square root. Okay, so now we are almost end of the session. So in this session we have discussed perfect square identification, we have discussed, and the prime factorization method we have how we can identify the perfect square and square root through the prime factorization method, and also we have also checked through the division method. So when they ask the square and square root, identifying the square and square root through so we also applied the division method, we also checked, and square root of a fractions where when the now given numbers are given in the form of the fractions, ask them to identify the square roots, that is also we checked, and the square root of decimals also we checked when the square root is given in the form of the decimals. Now how we can identify the square root of for the given decimals, that is also we checked, and the least number problems also we have seen, and also we covered some of the previous questions, and we along with the previous questions when we are trying to see, we also discuss the concept. Okay, thank you.